Hello and welcome everyone. So last time we talked about sum of square of n natural number. So k is equal to 1 to n. We write summation or sigma k equal to 1 to n, and we write here k. So which is same as 1 plus 2 plus 3 plus 4 plus, and you go up to n. And this was coming n plus 1 divided by 2. So this was the sum of n natural number we discussed in our last video. So today we're going to explore sum of square of n natural number. So when we square the natural numbers and we want to find their sum, so could you figure out some expression which could be uh, designed out of here? So if I represent this quantity by Sn, say I represent this by Sn, or in notation form, I can write it summation k is equal to 1 to n and k square. So I keep, you just put the value of k as 1, 2, 3, 4, and you get this expression. So if I have to find out this, let's consider this identity, say k plus 1 cube minus k cube. All right. Can we get the term of k square so that we could plug in some values and get some quantity like this? So it is k cube plus 1 cube, that is 1, plus 3k square plus 3k. You get this, and minus k cube. So this should be crossed out, and we get k plus 1 cube is equal to, this quantity comes k plus 1 cube minus k cube is equal to 3k square plus 3k plus 1. All right, so we get this expression. Now what can we do is we can put values of k in this expression. Can we write this left hand side as right hand side? Just for convenience. So what we are doing is we are writing this quantity 3k square plus 3k plus 1 on left hand side, and on the right hand side it comes k plus 1 cube minus k cube. No issue. Left hand side and right hand side has been exchanged, so identity remains same. Consider this identity. Now if I put the value of k here, 1, 2, 3, 4, and so on. So what we are going to do, put k is equal to 1, 2, 3, and go up to n. So what do I get here? When I put k equal to 1, I am getting 3 into 1 square plus 3 into 1 plus 1 is equal to, this become 1 plus 1, 2 cube minus 1 cube. Now put k equal to 2. So 3 into 2 is square plus 3 into 2 plus 1 is equal to, this thing become 3 cube minus k is 2 cube. And if I put k is equal to 3 here, this become 3, k is equal to 3, so 3 square plus 3 into 3. Now we are getting some kind of pattern here. 1 is equal to, this become 4 to power 3 minus 3 to power 3. So likewise, we will go on putting value of k, and what we get next. So we will put k equal to 4, we get some identity. For k equal to 5, I get one more, k equal to 6, and so on. Suppose I put now k is equal to k minus 1. So sorry, k equal to n minus 1. So this become 3 times n minus 1 square plus 3 times n minus 1 plus 1 is equal to, in place of k I put n minus 1, so this was actually k plus 1, so it became n cube, and this was k cube, means in place of k I'll have place n minus 1, so it is like this. Now put k is equal to n. Now this becomes 3 times n square plus 3 times n plus 1 is equal to, this becomes k is equal to n. So this quantity up here, if you see this quantity, it was k plus 1. So this become n plus 1. Hope you understand this. So this quantity is now n plus 1, n plus 1 cube minus n cube. So I have got all this stuff. Now, if you look at this carefully, the sequence you have got here, the pattern you have got here, okay, let's see this one, okay, here we go. So it's like 1 square, 2 square, 3 square, 4 square, you go up to n square. So how can you write it? You can write it this term, when you take 3 common here, the first column I'm adding, so I get 3 common, so this become 1 square plus 2 square plus 3 square, and it goes up to n square. This term, all this stuff, right? This column added. All right. Okay. Now plus, similarly we add the second column. This column I'm talking about. So that column is plus 3 times, which is 1 plus 2 plus 3, and this also goes up to n. Plus now this 1 n time, so plus n is equal to, on the right hand side, what you see, what is left. If you see the right hand side quantity, this has become, you see, let's see which is being cancelled out, which term is being cancelled out. If you see on the right hand side, this 2 cube and this 2 cube should go, this term should also go, 1 is left here, this 4 cube will go with some 4 here, and likewise if you go further here, this n, okay, this n cube should go with n cube, and this term should go with some number here. So all the terms get cancelled. I get n plus 1 whole cube here, and I get 1 cube here. So on the right hand side of this, you are getting, okay, so this quantity is equal to, we should write it here. So this quantity on the right hand side is n plus 1 cube, okay, minus 1 cube. Now, what is n plus 1 cube minus 1 cube? Let's write this thing. This thing, we said we represented this 3 times summation k is equal to 1 to n k square. That's how we can write. Plus, this is 3 times sigma k is equal to 1 to n and k. And this is plus n is equal to, expand this, a plus b whole cube, which is n cube, plus 3n square, plus 1, plus 3n, okay, plus 3n also. Actually, you can apply the identity, a cube plus b cube plus 3a square b plus 3ab square, and minus 1. This plus 1 minus 1 should be cancelled. And now, what we can do is, yes, we are interested in this quantity. We are interested in this quantity. All right. So we will keep this on the left hand side and we will proceed. So it is 3 times. if I can represent this quantity by Sn, I can say 3Sn is equal to, now this formula we had already learned. I will take this on the right hand side. So this becomes, or maybe right now you put in the left hand side itself and later take it to the right. So this thing becomes plus 3. This term will become n plus 1 by 2 plus n is equal to n cube plus 3n square plus 3n. This was it. So now 3Sn will be what? 3Sn is equal to, you can take everything on the right hand side now. This n will also go on the right. So this is, on the right hand side I have n cube plus 3n square plus 3n minus n minus 3 by 2 n plus 1. Like this. Okay, which is, you can take the LCM 2. 2 is the LCM, so you get 2n cube plus 6n squared plus 6n minus 2n, and this is minus 3n squared minus 3n minus 3n squared minus 3n. So what do we get? This quantity here. All right. So 3Sn is equal to 3 times Sn is equal to the LCM 2 here. So 2n cube as it is minus plus 3n square, no problem. And this is plus n. So we get 3Sn is equal to, we can take n LCM, sorry, n common, then it is 2n squared plus 3n plus 1. Now simply factorize it. Simply factorize it. So what do we get? We get this thing is equal to n as it is. This can be factorized, very easy to factorize. It's like n plus 1 and 2n plus 1. So divided by 2. This was 3Sn. So if I have find Sn, the 3 will come in denominator here. So I get finally Sn is equal to n plus 1 2n plus 1 divided by 6. So this was sum of square of n natural number. This is what we were interested in. So hope you like this, and if you want to see more videos like this, you can write in comment box. Also like, subscribe and share. Thank you.